Hi, everybody. With clean energy tech making breakthroughs left and right, our shores and seas couldn't stay behind. And this company is building incredible devices to once and for all harness the power of the ocean. Let me introduce Sea Power. Hi, everybody. This is another episode of Builder Nation. I'm your host, Sam, and today I am joined by Reenst Lesemann, CEO at Sea Power. Reenst, welcome. Thank you very much for joining us today. Could you please introduce yourself a little bit?
Sure. Thanks, Sam. As you said, Reenst Lesemann, CEO of Sea Power. Sea Power, we're a wave energy technology company.
A wave energy technology company, right into it. Let's dive. Thank you very much for that. Yes, actually, I've been taking a very thorough look into your website. It's amazing the technology you're building. Actually, I can see in your background that you have this digital image of what would be
Yes.
your devices, right? I believe the Sea Ray and the Stingray. We're gonna touch those in a minute, so let's not get ahead of ourselves. Could you please give us an overview of the objective of what Sea Power wants to do with this ocean energy?
Sure. So I think our mission's pretty simple. We look to bring the next renewable to the world. So ocean energy. That's our goal here. And everything we do from an innovative perspective is all about fulfilling that mission. How do we bring wave energy, ocean energy, into the energy mix on a global basis?
Right. Right. I mean, that is actually something that I believe it's a very important topic, right? Which is bringing this new one. How does this energy generation methods differ from probably the most mainstream solutions that are right now for eco-friendly solutions, which are maybe solar power, wind energy, wind power, etc. What is the difference with this?
Yeah, so wind and solar are obviously great resources, right? And wind and solar have grown up in a world where really one of the primary aspects has been how do we move to sustainable, clean energy resources away from carbon-based? That the world's changed a little bit, right? So we're now globally thinking about the energy trilemma. How do we create energy resources that are secure? How do we create energy resources that are affordable? How do we create energy resources that are sustainable? And so to be able to check those boxes, to be able to help answer that dilemma that we face globally, you need resources that are widespread, they have to be impactful, and they have to be energetic. And that's exactly what the ocean is. So the ocean, if you think about it, it's the biggest and best battery that we have on Earth. And what we're trying to do is tap that battery, right? And so it's going to be a group of three: wind, solar, and wave. That's the wave of the future for bad pun purposes.
All right. Thank you very much for sharing that. It's actually a very nice sort of way to what do you call it? Sort of close the trifecta, right?
Yes, sure.
So thank you very much for sharing that. Now, let's dive deeper straight into the technology you're doing, right? So as I mentioned before, you have built pretty much two sort of main tech for this, which is the Sea Ray and the Stingray. Before we get into anything, could you please explain to us what these two are?
Yes. So we divide the world really into two major markets. There is the offshore market and the onshore market. And while for us, the energy, the electricity that we make with our technology is produced offshore, where it's consumed matters. So in the offshore market, the energy is produced and consumed offshore. Think about the US Navy or offshore energy companies.
Right.
Onshore market is sort of the traditional mainland terrestrial grid market, so utility scale systems. We have the Sea Ray that is designed to meet the needs of the offshore market, and the Stingray, which is designed to meet the needs of the onshore market.
All right. Okay. So basically, it is sort of the output capabilities of these two devices that makes them the major difference.
Yeah, that's one. So most of the loads that we look to help our customers service, and it's about reducing cost and complexity and carbon intensity, whether it's the offshore or onshore market. And we have two basic technologies that they share DNA with each other. If we wanted to dive into the details, we could talk about that. But they share a common DNA but each is built specifically to serve the market that it is intended for. So the Sea Ray is what we call part of an autonomous offshore power system. It's
Okay.
a self-contained power and data mini grid. Think of it like a power strip in a Wi-Fi signal out in the middle of the ocean for robotics or data gathering systems or communications. The Stingray is meant to be a power plant. It'll be an array of systems out in the ocean in an offshore wave farm, just like you see with offshore wind, right? So it's same general concept, an array of systems that are all connected into the mainland grid.
Okay, okay, that is actually a pretty interesting difference. Thank you very much for sharing that. Now, I do want to delve into what you mentioned of these sort of shared DNA, right? What
Yeah.
is the core technology behind, I guess, the Sierra and the Stingray, which is, I assume, the core device or the core principle to
Yes.
harness, I guess, the kinetic energy of the ocean and transform it into electricity.
Yeah. So in every wave, there are really two forces. There's the heave and the surge. If you're at the beach and you're
Hmm.
in the surf, the heave is what, when a wave comes by, wants to lift you up,
All
and the
right.
surge is what wants to knock you towards the sand. One of
Okay.
the innovations for us, both of those forces, and utilize both those forces as we convert that mechanical energy into electricity. That's one. Survivability is another. So we don't have any metal on metal banging, so to speak, that
Right.
would go on in the ocean. So the systems won't beat themselves up because it's really important. Obviously, if you're in the ocean and we're there because of the amount of energy that's coming ashore or that's present in the ocean, you have to be kind of careful what you wish for, right? So with all that energy comes a lot of force. And anybody that's ever owned a boat or been on a boat knows that whatever you put in the ocean is going to break. So
Right.
survivability, reliability, affordability, those are critical aspects of what we do.
And now, actually, I have three different questions based off just on this single answer.
Sure.
Number one question that I have is, how are these devices capable of adapting to to chaotic and extreme situations that the ocean sometimes presents? I mean, call it a storm, a whirlpool,
Yeah.
you name it, right? The ocean is pretty unbiased in that sense. So how do you address that? How do they adapt to
Yeah, Mother Nature has no mercy sometimes, right? I think that's
it?
one way to think about it. It's so we have to obviously, and that you've hit on a critical part. You have to create a system that can survive a hurricane or survive the 100-year storm or the 200-year storm.
Right.
At the same time, it has to be cost effective in order to be able to create energy in light waves. So if you have a 1 meter wave or you have a 10-meter wave, you've got to be able to deal with that full range. And
Right.
that, truthfully, dealing with that wide range of potential waves coming at the system, that's one of the hard parts to deal with.
Right. I mean, it does seem like one of the hardest parts. The other question that I have that I also believe is sounds like it's gonna be pretty complicated is gonna be
Mhm.
maintenance. Like when you already put a system and that it's operating for years and years and years, just as any mechanical system out there, it's gonna require maintenance, right? So how do you tackle that for
Yeah.
these devices?
Yeah, and you mentioned the operative word complicated. Everything we do is intended, whether it's the technology design or the generator that we put in the water, it's meant to be simple. Simple in the ocean is always better,
All
right?
right.
So we actually use off the shelf for the Sea Ray. These are generators that come off the shelf. You can order them online when you want to. Now, the system that we've created in order to drive those generators is unique and innovative. For the Stingray, the utility scale system, it is, we have an advanced version, but it's really the same basic technology you see in an offshore wind turbine. That is somewhat unique to
Okay.
us. And we have a proprietary design for that. So simple rotary motion with generator technologies that are well understood and well accepted worldwide. We're not trying to do anything too complicated or too many moving parts, too many pieces, because as you say, those things are going to break. And then how do
Yeah.
you maintain? Um, the Sea Ray, it's by its nature a smaller product, It rides low in the water. It's intended to do that. So there's not a whole lot of maintenance that goes on with that. There's a twin strategy. You got one on the dock, one in the ocean. So
All
when it
right.
comes time to maintain it, you pull it out, swap it out, just like in a server farm, your blade servers, you're pushing in and
Right.
pulling out. Whenever you have to switch them, same general concept.
Right.
The Stingray, which is much bigger, can be maintained at sea.
Okay. All right. That's actually, I didn't really expect that to be the answer, but it's good to know that you've sort of made it a lot simpler, right? So thank you very much for that. Now, the last question that I have is more or less a comparison between two technologies that I believe are similar, right? On the one side, we have the Sea Ray and the Stingray, which is basically they harness these, the wave energy, right? But
Right.
then there is other type of energy generation system on the ocean, which is pretty much with the force of the waves, right? When they crash, it's sort of a percussion kind of system, right? I
Yeah.
don't know if you know about it, but how do you compare the sort of the energy output of wave energy to the actual energy that generates from crushing, maybe a wave crashing into this device that harnesses that electricity? How does that differ in terms of efficiency, maybe?
Yeah, and that gets back to what I mentioned earlier about be careful what you wish for, right?
Right.
So a breaking wave is a destructive wave.
Mm-hmm.
A swell, so if you think about an ocean swell, which
All
is
right.
not necessarily breaking, I mean, in a nasty, nasty storm, of course, it would
Mhm.
potentially have some breaking capabilities. But we're trying to harness that energy out of the swell as opposed to what we would consider the more destructive breaking wave, where you really
Right.
have maintenance and other survivability issues. I mean, the energy that's present is present, right?
Right.
And most of the energy is on the surface. So you'll see some technologies that like to be below the surface or even on the seafloor.
Mm-hmm.
I think our view is that you need to be on the surface. That's where most of the energy is. And you got to build a system that solves that trilemma of affordable, it's acceptable from an environmental
Right.
perspective, right? And it's always available. And those three things, available, affordable, acceptable, that's really what our technology development process and testing and evaluation all revolves around, solving that trilemma.
All right, thank you very much for that.
Yeah.
And speaking about trilemma, pretty much, or about these three main things that you address as power, you already mentioned it in the past, which is reducing cost, complexity, and emissions for offshore operations. Right
Yeah.
now, jumping more into the whole system, how do you actually solve these three things, right? And how does the full system of operations looks like for the Shira and Stingray, all the way until it actually provides the electricity to the grid or to a house or whatever it is plugged into?
Right. All right. Well, let's start with the Sea Ray. So
Yeah.
offshore market, so energy that gets consumed there. And our wave energy system, actually the Sea Ray is a hybrid system,
Okay.
is fixed solar on board the system and wave. So we're taking the best
Mm.
of both worlds. Because what's important there for the customers in the offshore market is energy availability. The cost of the next electron is not necessarily as important to them because what they're doing now, they're using liquid fuel. So it's bunker fuel for a vessel or diesel fuel, or
All
they've got
right.
a subsea power cable. So they're not necessarily worried about the cost of energy like we would be for utility scale systems. So we create energy on the surface. You can see the Stingray here back and the Sea Ray
Right.
over on the other side. We make electricity on the surface. And for the Sea Ray, we keep a battery charged. And then whatever we're supporting in the ocean, that power strip I mentioned,
Mm.
it plugs into that battery. So we keep the battery charged and the device lives off of whatever we're supporting, maybe a robotic system or a data gathering system or all the above. It lives off the battery. The Stingray also makes electricity by capturing that mechanical energy, converting it to usable energy on the surface, and then it is cabled and connected to the shore for the most part. Now, a Stingray can also operate in the offshore market but for I think purpose of the discussion, that concept of operation is any electron that's made on the surface goes through the
Mm-hmm.
cable and connects into the mainland grid.
All right. Okay. Thank you very much for sharing that insight. It's actually pretty
Yeah,
cool to know how the whole system kind of looks like. Now, I want to talk precisely about this battery type of generator that you mentioned, right?
yeah,
To store it, and I wanna relate that to something that is moderately, prominent and popular on your website, which is the allocation of this, or pretty much the connection between these batteries
yes,
and autonomous vehicles for water, whether that is underwater or maybe USVs, for example.
yes,
So I would like
yeah.
to ask you, what is the role of sea power, and that sea power is playing for the future of these very advanced uh, sea vehicles?
Yeah. So if we go up a level and think about, and it's probably what you talk about on the podcast all the time, is you think about electrification and decarbonization and robotics and autonomy,
Yep.
digitization, all those trends which have dominated the terrestrial economy for decades now, they are really slow to come to the ocean. And that's because
Mm,
the ocean is a power desert, right? There's plenty of energy. It's kind of like the water everywhere, but not a drop to drink kind of
right.
throw. But what we do is we take the ocean and turn it from a power desert into this energized, data rich environment. And by getting over that lack of power obstacle, and having power enables data, what that allows our customers, that allows electrification and decarb and
Hmm.
digitization and robotics to come to the ocean economy. So we have a tremendous number of partnerships that we are working on with a variety of robotics customers and data gathering partners to make their systems better, stronger, lighter, faster. I think one of the
Right.
analogies I use, it's like the old BASF tagline: "We don't make the things you buy, we just make them better." Right? So you take somebody's robotic system, which currently requires a vessel topside. So
Right.
that's a crew, and that's a ship that's burning, diesel fuel or bunker fuel. Really, one of the dirtiest. The offshore market's one of the dirtiest energy environments that we have on Earth, and so we remove the need for that vessel and crew,
Mm.
and that's where we are. So that is enabling those robotic systems to flourish offshore, where right now they are handicapped in how they can proliferate because power is the rate limiting step.
All right. Well, thank you very much for sharing that. Now, I guess that it is time in this moment to sort of go even a step further, right? And it is to ask about the main difference of why somebody would choose, for example, maybe a sea ray or a stingray or whatever,
Mhm.
versus say in the in the coast or in the shore or whatever, maybe
Yeah.
solar power. Why would somebody go for sea power?
Yeah, that's a well. Look, I think it takes a village, right? It takes a diverse portfolio, just as financial investments require a diverse
Yes.
portfolio. The global energy mix requires a diverse portfolio. So
Mm-hmm.
it is wind and solar and ocean wave energy together, which can provide reliable, consistent, affordable, clean energy resources.
Yes.
So I don't know if it's as much as, hey, choosing this one over that one, as much as it's going to take a diverse portfolio in order to really to crack this problem of removing the
Mm-hmm.
global energy mix from a carbon-based resource.
All right. Well, thank you for sharing that. Now, this then delves deeper into this. Now we, for example, know that there is a very popular concept among solar power, which is solar farms, right? Which are
Yes.
arrays and arrays of solar panels, right? And that pretty much generates tons of electricity. So the number one question that I have on this is, how much power can the Syria and the Stinger generate in, say, a day or a week, or whatever? And
Right.
is something as like the concept of ocean energy farms something possible or doable or recommendable?
Right. One of the reasons that we believe ocean wave um, uh, can rise to the level of wind and solar, will rise to the level of wind and solar, is because it's an energy dense resource, right? It is
Hmm.
multiples of wind energy. It is many, many multiples of solar energy.
Yes.
Um, it moves relatively slow, and that's part of the ocean does. Waves move relatively slow. So part of the trick is being able to take what you have and turn it into usable forms of electricity.
Right.
But the offshore wave farm for like the Stingray, offshore wave energy for the US could handle a very material amount of the electricity consumption on an annual basis for the US and for global aspects. So there's a match to bringing all these resources together. But offshore wave farms, which you asked about, in general, the concept is no different from an offshore wind farm, but I think better, right? You don't
Okay.
have the view shed issues. Um, so you're not necessarily trying to convince people that, okay, we've got spinning blades. And again, wind power is an awesome resource, but offshore wave farms offer sort of that next step of an impactful energetic resource that gets captured and converted into affordable electricity. Now, we have innovation work to do to drive it to be cost competitive with wind and solar,
Hmm.
but from an offshore wave farm versus an offshore wind farm, it's a great opportunity. And in fact, I think what you will see is a combination of the two. So you'll see hybrid farms that have both offshore wind, whether it's fixed or floating,
Right.
and offshore wave systems. So think about a Stingray wave farm that is intermixed with an offshore wind farm.
All right. Actually, that is one of the questions that I had about how maybe not modular, right? Because well, the Stingray and the Sea are very tight. But well, how could you actually combine these technologies? Now, as of this moment, would you actually say that one of those use cases would be precisely to combine these technology with maybe another one, and that would be recommendable, or is it very specific to the situation of the user?
Probably a little bit of both, but I think that especially early on for Wave, the ability to interconnect into the infrastructure. So you think about the electricity, the infrastructure, the equipment that's on the seafloor, the cabling to go in an offshore wind farm to collect and push all those electrons into the terrestrial grid.
Right.
Really what we're talking about when you intermingle a wave farm and a wind farm is we're just tapping into that same infrastructure. So you're taking
Mm.
that same cost and dividing it over much more resource. You're really doubling the potential energy that can come in, or at least what is theoretically possible to come in. So it's I think it's a great idea, and I think that's where we'll see the first waveforms of size that they'll be intermingled or
Mm.
on the same infrastructure backbone that you see offshore wind farms.
So you do see something possible to sort of take
Absolutely.
existing farms that are already there and just sort of add this as an addition without really making major tweaks to these farms that are currently existing.
Whether or not you add on to an existing farm or it's new builds, greenfield
Right.
developments, I don't know that I have a strong opinion there.
Hmm.
Um, but I think that there is enough installed capacity coming down the pipe, whether it's in the US, Europe,
Right.
Asia Pac. There's enough offshore wind capacity that's going to be coming online over the next 30 years that there's plenty of opportunity to create hybrid farms for greenfield developments.
I agree that it's going to be pretty impressive to just see the Syria and the Stingray sort of scatter around the world. But now, taking it back a notch into the more local and not so into the future uses,
Yeah.
I do have the question about, is it very different, for example, to sort of install these in different types of shores, maybe in the Pacific versus the Atlantic, or is it sort of the same principle? Also, are there maybe some recommended areas where maybe the shore is typically a little more consistently higher, maybe, so they can harness more power? Like, what kind of these specific details care about that?
Yeah, another great question, Sam. So for the Stingray, at least starting out, western facing coastlines that have a long open fetch of water. So think
Hmm.
about west coast of the US, west coast of Europe,
Right.
where the wind is transferring and the sun is transferring all that energy into that big battery that we've talked about.
Right.
Those tend to be the most energetic resources. So that's where you'll
Hmm.
see, at least initially, I believe, offshore wave farms like with the Stingray, so an offshore Stingray
Right.
farm connecting into the grid. And then as the technology becomes more and more cost competitive as we go forward, then you'll see it proliferate into lighter wave environments. No real difference between Atlantic and Pacific or other oceans for that matter. The Sea Ray, so thinking about the offshore market
Right.
now, where those aren't grid connected, that system is specifically designed to be deployed anywhere: shallow water, deep water, tropical zone,
Oh.
temperate zone. It is literally a Swiss Army knife. I keep throwing analogies at you, but it's a Swiss Army knife that's meant to be deployed anywhere to support anything at any time. So that
Wow.
is really the design mantra behind that system.
That's actually pretty cool. I didn't really know it was capable of going anywhere. I really did expect an answer more like, oh no, it's on this coast or that coast. But it's great to know that there are really no real hotspots for this. That's actually pretty cool. So thank you.
When you think about, regardless of whether it's the US Navy or an offshore energy company or NOAA doing oceanographic research or any international entity like those, their basic need is the same,
Right.
right? They have different parts of the world that they're thinking about or they're focused on or they're operating in or they've got activities going on in. But the common denominator is they're in the ocean. They need power. They need comms. And that's what a Sea Ray is intended to do. So we
Right.
will be able to put those anywhere in the world as we finish off that product line.
Right. And that is also another question that I have that is more related to your, I guess, CEO business side of this, which is how different is it to deploy this technology in different parts of the world where they have different,
Mhm.
guidelines and laws, etc. How different is it, and how challenging can it actually be to where the moment where you actually want to deploy it?
Yeah. Permitting issues. So for the Stingray going forward, those
Hmm.
offshore wave farms, if
Right.
you think about all the gigawatts of installed capacity that offshore wind is dealing with now, that just makes the permitting issues for an offshore wave farm that much easier. So we really kind of riding
Mm.
in the bow wake of offshore wind from a
Right.
permitting perspective. Some places are harder than others for sure, right? And you've got to get permission to connect into the grid. We're not really project developers. We're technology. We're equipment providers. We're an OEM, a manufacturer,
Right.
supplier of equipment. Project developers, power producers, utilities, they're the ones that will do they'll
I
build the
see.
offshore wave farms. We would supply that just like
Got it.
a Siemens or someone else would supply wind turbines into
Mm.
offshore wind project developer. A Sea
I
Ray
see.
is different, right? So a Sea Ray, we're much more probably involved in the deployment of that system. Those are smaller, self-contained. There's no grid connection. They're usually operating in a place that people are already operating now for vessels. So it's much less of an issue as far as the permitting overhead. Logistically, we designed that Sea Ray so you can ship it in ocean containers. You can ship it anywhere in the world. You can deploy it with very simple, smaller vessels. It's meant to be easy to move,
Mm.
easy to handle, easy to deploy, easy to operate.
Right. Well, I mean, I guess I didn't really think about that, but yes, it is true that you're gonna be more about this sort of providers rather than the installers, right? But it's interesting to know these major difference between the Siri and Stingray. So,
Yeah.
thank you for sharing that. Now, I want to move into a more businessy side of this as well, right? And you already mentioned this. For example, the U.S. Navy, right? You have partnerships with the government for the U.S. Navy and for the Department of Energy, as far as I understand. My question to this is: how have these partnerships impacted the development and maybe the reach of sea power and their devices?
Sure. The work that we've done, the sponsorship that we've received from the Department of Energy, the Navy, we've done a DARPA project. That's been critical, right? Without that support, it would be impossible to move from that idea that's in
Right.
somebody's that whiteboard concept to being able to deliver hardware like we're delivering hardware now to solve real problems in the ocean for people, to deliver
Right.
a value proposition for them that is meaningful. So we are incredibly grateful to the Water Power Technologies Office, to the U.S. Navy for the support that we've received because it's been critical.
All right. Well, thank you. It's glad to know that. I would assume this is completely out of just bliss ignorance, right? But I would assume that it's very difficult to find investors for these type of technologies that are very complicated to actually come and bring to the market. Or has that been not so difficult?
Well, if everything was easy, then everybody would be doing it, right?
That is
So,
true.
everything has its own level of difficulty. Our team, we've got this incredible team here in our Oregon office and on the East Coast in our East Coast office that they make pulling off and accomplishing tasks and bringing in funding in order to do what we need to do. They really simplify that. So, thanks to our team, thanks to our public sponsors, and to our private investors who have supported us along the way. Nothing's ever easy, but they certainly do make it easier on us.
And that's it's pretty good to know that. Now, I also have another question that is related to these, challenging sort of aspects of a business, especially in a company like Sea Power, right? That has been going on for I think almost 20 years or a little longer than 20 years, right?
Not
Which
quite that long, but yeah, yeah.
it's
So
been a long time, though.
yeah, it's been a while. Yeah, sure.
It's been a long time, definitely. My question to this is, over the course of these years, there have been challenges, for example, the pandemic, in terms of supply chain, in terms of manufacturing, and in terms of procurement logistics, right? So, how did Sea Power well serve those challenging waves?
Yeah, so COVID and we felt the supply chain problems just like everybody else. So whether it's finding space on a ship and getting things shipped from overseas
Yeah,
to our office, just the day-to-day work impacts of people working from home. That we fought through it just like everybody else has fought through it, right?
mm,
Things were significantly more expensive, more difficult. I think what comes out of that though is we've returned to, if there's ever a normal state, we've started to return to more of a normal state. The analogy I use is like a baseball player, right? Before they step up to the plate, there's a weight that they put on the bat to help them swing faster. So I think the pandemic for us presented a lot of weight, just like it did for everybody else. We've
mm.
practiced with that, and now that we're at the plate, we're able to swing a little bit faster. So um, it was a very difficult time for a lot of people, but I'm really happy about how the team persevered and we were able to work our way through it.
It's very happy to see a company succeed, especially after such hard, times. And how would you say that the sort of workflow within the team changed after the pandemic? Maybe in terms of, I don't know, procurement processes or engineering development, R&D, etc. How different was this whole sort of workflow?
We had started to spread a little bit away from centralized offices
Mm.
before the pandemic hit. So we were kind of already heading down that
All
pathway.
right.
Um, and I, I worry probably like um, a lot of people. I worry about not having people in the office. We've done what we can from a collaboration and from pulling tools in to help streamline that. As we hire new employees, I worry about them being able to socialize and get to know everyone and learn
Right.
those quote unquote water cooler discussions that are a little bit harder when you're not face to face with people. So,
Yeah.
like everybody else, we've had to fight through those issues, and I worry about it. And I don't know that there's any silver bullet to solve those problems. We're in a different world now and how we operate on a day-to-day basis. But I'm proud about how we've pulled through it.
Well, I'm glad that it all worked out in the end. I do agree with you that it is definitely necessary to sort of have that in-person experience, right? But yes, it's definitely the times called for it. So thank you for sharing that. Now I want to go back into sort of Sea Power's news, right? And one of the things that I'm most interested in asking you is about a recent in-harbor test that was successful, right? I mean, I'm not saying recent as yesterday; it was definitely a couple months ago, but I believe that this is a very important milestone. You made a harbor test for the Sea Ray back in the day. It
Mhm.
was a 6-month pilot, if I'm not wrong, and it is leading you into, I believe, some sort of like a new test, right, for the Hawaii Ocean Energy Test. Could you please give us an overview of what this is and what this means for Sea Power?
Sure. So the Sea Ray is an incredibly innovative system. Um, and it is the first built for the purpose of supporting the offshore market, as we
Mm-hmm.
describe it. So that we were able to do a test deployment in Honolulu along with some of our partners. And we are literally today prepping to put it out
Oh,
in Hawaii on Oahu. There's a Marine Corps base. We're going off the shore of the Marine Corps base with that system. Hopefully that'll happen within the next week or so. But when we are in the water, we'll be supporting a couple different assets. A system that sits on the seafloor to monitor the environment, to look for intruders. So it's an intrusion detection system, an environmental
mm,
monitoring system, a mammal tracking system. So it has multiple purposes. And we'll also be supporting a Saab Sabertooth AUV. So one of the most
okay.
advanced AUVs in the world will live and be supported by the Sea Ray when we're deployed off the coast in Kaneohe Bay and in Oahu. So that it's really cool what's going to happen there. Um, so we are connected to the internet through a cell signal, and the
Mm-hmm.
instructions to that AUV will be sent through the Sea Ray to the docking station. The Sabertooth will get that. It'll go off, do its work, come back, dump the data, get recharged, get a new task, and we'll just rinse and repeat that cycle for a number of weeks. And that'll be the first time ever that a non-wired robotic autonomous system will be operated with an
Wow.
offshore energy system. So that's going to be really exciting. So I think that's really typical of the innovation that we're driving worldwide here with our technology. And
Wow.
it's going to be exciting when we're able to get that done.
And are the plans to keep to be able to integrate with virtually any vehicle, or in this case, this test is made specifically to integrate seamlessly with these? You mentioned the Saab Sabertooth AUV, right?
Yeah, I'll go back to that anytime, anywhere, anything tagline that I said a little bit earlier. The Sea Ray is intended to support whatever asset, whatever piece of equipment, whatever sensor package that anybody would need. So when I say it's a power strip and a
Mm,
Wi-Fi signal in the ocean, that is exactly so you're going to be able
wow.
to plug anything into it, and um, that's really the goal here. So operating equipment for offshore energy, being able to provide robotic systems for the U.S. Navy or research or whatever goes on in the ocean. We're agnostic to that. We're here to support whatever gets thrown at us.
All right, and that's actually a very very nice what do you call it, like a motto, right, or like a mantra. I like that. Thank you very much for that. Now we're approaching the end of the interview, but not before a couple last questions. The number one question that I have, which it's honestly something that I don't know if you have the answer to, but who better to ask, right? How how much do you think the future of these decarbonation technologies is sort of how long are we until we get there?
Wow. So that's a great question. I don't know if I know the answer to that. I know that we will never get there if we don't continue to push new resources, new innovation, new technology into the mainstream. Um, so what we have today in wind and solar, it's not enough for the onshore
I
market.
agree.
Offshore market, there are no solutions really except for ships and crews or power cables that are burning probably carbon-based energy anyway. So it is when exactly we get there, I don't know. How we get there, I understand how we get there, but we can't stop pushing. And that's really one of the things that drives us.
I mean, I really like that mentality, and with that, I want to delve into what is probably my last question here for you, Reenst, which is knowing on the one side that you are the CEO of this super massive and important company for clean tech, right? But also knowing that you have a lot of experience leading companies, right? You've been managing director and CEO, not just of CPower, but of many companies in the past. My question is, what is the advice or the comment or the idea that you would like to share out there with the world, with young engineers and entrepreneurs, and just straight up just young people who are starting their own path, uh, to help them keep these, effort that you're doing to keep pushing these technologies to reach that decarbonized? What is that thing that you would like to say?
Yeah. Um, those are I think my advice here is always same advice that I give my kids, right? Do something that you're passionate about. And it may sound a little hackneyed, but it is absolutely true. Do something that you're passionate about, because if you're not passionate about it, you're not going to enjoy it. You're not going to be behind it. You're not going to do the things that you have to do, make the sacrifices that you're going to have to make in order to see success. So get behind something that you want to be behind. And it you can't be afraid of failure, right? So that's a hard thing for sort of any startup. There's going to be changes in the path. Be ready to accept those issues, pivot when you need to pivot, but keep driving forward because you'll get there eventually, but it's never easy, right?
I agree. It's never easy, but I mean, I thank you for that experience. I believe that it is very valuable coming from somebody with so much experience as you, right? I would assume that you have encountered jobs or maybe companies or whatever that you're not really 100% passionate about, right? So it's nice to know that. So thank you very much for that, Reenst. I don't know if you have any last comments for the audience who are gonna see these right now or in the future, who might be also starting their own career or their own path. Any last comments, maybe any sort of not advice, but any last thoughts that you would like to share?
No, I guess I'd make a request of everybody in the audience. If clean energy that is sustainable, reliable, impactful can help support what you're trying to accomplish, we are all about trying to make things better, cleaner, faster. So whether you have a robotic system or a data gathering system, or you got a problem, you need power, we're here to help, right? And we're here to help drive new innovation into the marketplace. So I don't know if I'm a great person to give anyone advice, but we're here to help and would love to help people succeed and solve the problems that they have around energy.
That is amazing. That's so kind of you. Thank you very much. I believe, Rins, that is the perfect way to actually finish this, and it connects perfectly to the final part of this, which is where can we find you and where can we find C Power? What are your social media handles and website?
Yeah, so I would say the easy way is to find us on the web, cpower.co. So the letter C, POWER.co. You can get contact with me and with Christy Terrasa, who works with me, really anybody in the company from the website. We're on LinkedIn, etc. So, come learn more about us. Come to the web, come learn more about us.
I do recommend going and learn more about you because we didn't touch as much as I would have probably liked, but I mean, I understand that time is essence here. But thank you very much for sharing all of these insights and your knowledge on this tech and on the industry. Now, everybody else, please remember that you can find more information, interesting articles, and interviews directly on our website, buildernation.io. We're gonna love to hear from you. Thank you again for being part of this community. It means the world to us. We're gonna see the next episode. And Reenst, thank you very much for being here with us today and sharing your expertise. It's been invaluable. Thank you very much.
My pleasure, Sam. I really appreciate it. It's a great conversation. Thank you.
It was a great conversation. Thank you, and goodbye, everybody.
Bye.
When building the future is your priority, tedious procurement processes should be last on your list. The problem is that purchasing data is scattered across spreadsheets, receipts, emails, and messages. Tracking it all sucks and makes it easy to commit mistakes. Introducing the Control Hub Way, the all-in-one purchasing software for hardware companies. Buying parts, services, or office supplies? Submit a quick purchase request to buy from your list of approved vendors, or buy from a new provider. Buying from approved vendors is even easier. Import your shopping cart directly into your purchase request using our checkout integrations. When the order is ready, submit it for approval. We'll ping all pre-designated approvers both via Control Hub's website, email, and Slack notifications for a faster turnaround. If you need a PO, we got you. Generate it in one click. Online purchase? Boom, virtual card. Do an automatic 3-way match, pay invoices, and sync everything live with QuickBooks or NetSuite. Purchasing just got a lot easier. Control Hub. Get back to building.